In this lecture, we are going to discuss about period of functions. We have learned about periodicity of functions in our boards class, but here I am going to teach you a method which will help you to evaluate period of functions in quick succession. I will suggest you to learn this method first. Don't judge at the beginning. After knowing the process of evaluating period of functions, later you decide which method to apply in the examination to evaluate the period quickly. If you like the method, don't forget to give a thumbs up. If you have any comment regarding this process or any other suggestion, write it in the comment section below. Those who are new to the channel, don't forget to hit the subscribe button and press the bell icon to get notified for all new videos uploaded. Let's start this method. This method is what called your quadrant method. Now let us take our first example. See, fx is half mod of sin x by cos x plus mod of cos x by sin x. This kind of problem we will solve it by quadrant method. So to evaluate the period of such kind of function by using quadrant method, we have to remember two very important things. First is, in the quadrant, this is our first quadrant, this is our second, this is third, this is fourth, this we all know. The first point to be noted is, we have to write this function in every quadrant accordingly, removing the mod sign. The trigonometric ratio with mod sign will be removed with a positive sign if that ratio is positive in that quadrant, or it will be replaced by minus of that trigonometric ratio if it is negative in that quadrant. So in the first quadrant, we will write half. In the first quadrant, sine as well as cos is positive. So it will be nothing but sin x by cos x plus cos x by sin x. That gives you half tan x plus cot x. Is it clear? Now let us move for the second quadrant. In second quadrant, sine is positive and cos is negative. So our function will be written here as so we are having half tan x minus cot x. Is it clear? Now, in the third quadrant, sine as well as cos are negative. So our function will be written in the third quadrant like so it will be half minus tan x minus cot x. Okay? And in the fourth quadrant, sine is negative and cos is positive. So our function will be half minus tan x plus cot x. Is this clear? So what I have done in the first step is, I have simply written the function in each quadrant and we have removed the mod sign if in that quadrant that trigonometric ratio which is in the mod sign is positive. So we have replaced that mod sign with a positive one, and if that trigonometric ratio is negative in that quadrant, we have removed the mod sign with a negative one. That much we have done right now. Is it clear? So this is the first point to be noted. Now the second point which one should remember is that in each quadrant you have to observe that the trigonometric ratio that we are getting is positive or negative in that quadrant. If it is positive, we will leave the trigonometric ratio as it is. But if it is negative, I will put a minus sign before that trigonometric ratio. Is it clear? So in the first quadrant, tan is positive, cot is positive. So leave it as it is. Come to the second quadrant. In second quadrant, tan is negative, cot is negative. So we have to replace this like half minus tan x plus cot x. Have you understood this? Have you understood this? What I have done in the second quadrant is, in the second quadrant both tan and cot are negative, so we have rewritten the function with a minus sign in each of the trigonometric ratio. In this case it is tan x and cot x. In the third quadrant, tan x as well as cot x is positive, so leave the function as it is, don't touch it. In the fourth quadrant, tan is negative as well as cot is negative, so we have to rewrite this function as half tan x minus cot x. Is this clear? So in the first quadrant, our function is half tan x plus cot x. In the second quadrant, our function is half minus tan x plus cot x. In the third quadrant, the function is half minus tan x minus cot x. And in the fourth quadrant, the function is half tan x minus cot x. Is this clear or not? Now, these are the two things that we have to remember. So let me just revise once more. What we have done is, we have rewritten the function in each quadrant, removing the mod sign. How we have removed the mod sign? We have checked that in that quadrant, if that ratio is positive, I have removed the mod sign with a positive sign. And if that ratio is negative, I have replaced the mod sign with negative sign. Is it clear? This is the first step that we have done. And in the second step, what we have done is, whatever derived function we got in each quadrant, we have checked that whether that ratio is positive or negative in that quadrant. If it is positive, we leave that function as it is. And if that ratio is negative, we have written a minus sign before that ratio. Is it clear? So these are the two steps that we have remembered. Now, the third and the last step is that you should always start your journey from this point and go in the anti-clockwise direction, right? So first, when you start your journey from this point, every time you should start your journey from this point. I mean, from the positive direction of the x-axis, and go in the anti-clockwise direction. So once I started my journey, I have seen the function half tan x plus cot x. Is it clear? We have started the journey and we have seen the function half tan x plus cot x. Now your task is to go around this quadrant and find where you can get this function back. That is half tan x plus cot x, where you are getting this function back. So if I start from this point and if we move till here, now we can see the function as half into minus tan x plus cot x, which is not same as this function, right? So again you revolve. You came to this point. Now I can see the function like half minus tan x minus cot x. Again, this function is not same as half tan x plus cot x. So we have to revolve again. Move in the anti-clockwise direction and come to this point. Now you see the function which is half tan x minus cot x. Again, this is not same as half tan x plus cot x. Yes or no? Now you revolve and come to your original place. Now you can see the function half tan x plus cot x here, which is same function that we have seen in the beginning of our journey. Is it clear? So, when you came back here, you can get your function back. Now, how much you have revolved? You have revolved 2 pi. Yes or no? You have revolved 360 degree. That is 2 pi you have revolved. Therefore, the period for this function will be 2 pi only. Straight away you write it down. Is it clear to everyone or not? Okay, let me take another example. See this one. So for this function, what I'm doing, the first step, that I have to remove the mod sign in the respective quadrants. So in the first quadrant, it will be, here sine and cos are both positive, so we got tan x. In the second quadrant, where sine is positive and cos is negative, so the function will be, is it clear? In the third quadrant, the function will be where sine and cos are both negative. Is it clear? So we are getting minus tan x. In the fourth quadrant, sine is negative, cos is positive. So the function becomes Is it clear? Now, this is the first step that we have done. In the second step, we have to find out whether the ratio, trigonometric ratio that we are getting in each quadrant is positive or negative. Accordingly, we will put the sign. In the first quadrant, tan x is positive, so it is positive. We are leaving the function as it is. In the second quadrant, it is 0, so no need to check it. In the third quadrant, tan x is positive, so don't touch it. In the fourth quadrant, 0 is coming, so no need to put anything, right? Now, the third step, that is, we have to start the journey from this point, looking at this function, which is nothing but tan x. So I have to revolve in the anti-clockwise direction, and we will see where this tan x is coming. Wherever this tan x is coming, we will stop there, and the amount of revolution that we have done will be the period for that function. So from here, if we start the journey looking at tan x, now if we revolve here, we come here, we see that 0 is here, right? It is not your tan x. So we have to move again. We came here. Now we can see minus tan x, which is not equals to tan x. So again, we have to revolve. We came here. Now we see 0. 0 is not tan x. Therefore, we have to again move. So we came here. Now we can see tan x. So we have started the journey looking at tan x, and now we are at a place where we can see that function is coming, which is tan x in this case. Is it clear? Therefore, the amount of revolution that we have done is nothing but 2 pi. Yes or no? Therefore, the period for this function will be 2 pi. That's it. It's so simple. Is it clear? Now let us go for another example. In this question, we have been given that fx is half mod of sin x by mod of cos x plus sin x by cos x. This time I will do it little faster. So the first method is we have to remove the mod sign accordingly in each and every quadrant. So I'm doing it little fast. Please check it. In the second quadrant, is it clear? In the third quadrant, and in the fourth quadrant. So the first step is over. Now we have to check the sign for every trigonometric ratios that we are getting in each quadrant. First quadrant, tan x is positive, leave it as it is, 0, no need to check anything. Tan x. In the third quadrant, tan x is positive, so leave it as it is. Fourth quadrant, it is 0, so no need to check. The third step, we have started our journey from this and we are moving in the anti-clockwise direction looking the function tan x. Now we have to see where we are getting tan x. We revolve till pi by 2, we can see 0. So 0 is not tan x, forget it. Again you revolve, you came here, now you can see tan x. Yes or no? So when you came here, at this point, you can see the function as tan x. This is exactly the same function which we have seen in the beginning of our journey. We got our function back. Therefore, we have to check how much we have revolved. In this case, we have revolved only pi. Therefore, the period for this function will be pi straight away. Is it clear? Let us take another example. See, in this case, we have been given that fx is half times sin x by mod cos x plus mod sin x by cos x into cos x, right? So I'm writing it, removing the mod sign in the respective quadrants. So I'm doing it a little fast. I hope you can now understand. Please see it. Is it over? Now, the second step, we have to check the sign of the respective trigonometric ratios that we are getting in each quadrant. So, in the first quadrant, sin x is positive, leave it as it is, 0, no need to change anything. In the third quadrant, sin x is negative, so we have to change this minus sin x as plus sin x only. In the fourth quadrant, it is 0, so no need to change anything. Now we will start our journey from this point, moving in the anti-clockwise direction, looking at the function sin x. So if we move here, we are getting 0. So it is not your sin x. Move once more. We are coming here. Now we can see the function sin x. Stop here. The moment you get this function back, you stop there and see how much you have moved. You have moved only pi. Is it clear? Therefore, the period for this function will be pi straight away. Is it clear to all of you or not? So let me take a last example. See this question. Fx equals to mod of sin x plus mod of cos x. This sum came in West Bengal joint entrance for several times. Okay, so learn this one, how we can solve this problem by using quadrant method. So the first step we are applying, we are removing the mod sign in the respective quadrants. Just check it, I am doing it little fast. In the second quadrant, sin is positive, cos is negative. Therefore, in the third quadrant, sin and cos are both negative. Therefore, and in the fourth quadrant, sin is negative, cos is positive. So, now what we will do, this is the first step that we have done. The second step is, we have to check the sign for the respective trigonometric ratios that we are getting in every quadrant. Here sin, in the first quadrant, sin and cos are both positive, so just leave it as it is. In the second quadrant, sin is positive but cos is negative. Since cos is negative, the sign of cos x has to be changed. The sign of sin x will not get changed because sin x is positive in the second quadrant. Therefore, in the second quadrant, your function will become sin x plus cos x. Am I correct? In the third quadrant, both sin x and cos x are negative. Therefore, your function will reduce to sin x plus cos x. I have simply changed the minus sign with plus sign because as I told you that if you find the trigonometric ratio is negative in that quadrant, you have to put a minus sign before that ratio. Is it clear? So accordingly, it will be sin x plus cos x. In the fourth quadrant, sin x is negative. Cos x is positive, so leave cos x as it is, but sin x has to be replaced by minus, so it will be only sin x plus cos x. Am I correct? So second step is over. The third step is, we have to start our journey from this point, move in the anti-clockwise direction, looking at the function sin x plus cos x. Is it clear? Now if you move from here to this point, now you can see the function sin x plus cos x, which is exactly the same function what we have seen at the start of our journey. So we have seen the same function sin x plus cos x, which exactly you are getting here. Therefore, the amount of revolution that you have done is nothing but pi by 2. Yes or no? If it is pi by 2, then you will write that the period of this function is pi by 2 straight away. Is this clear? Is this conception clear to everyone? Okay. Now let us try to do some other problems in finding the period of function which is not directly related to the method that I just taught you, which is the quadrant method. Okay? See this question. They have said that fx suffix I is signed to p suffix I x, and this is true for all I equals to 1, 2 and 3. And they have said that the period for f1x minus f2x plus 3 times f3x is pi. Now the period for f1x will be 2 pi by 2 p1, which is nothing but your pi by p1. Is this clear? The period for f2x will be 2 pi divided by 2 p2, which is equals to pi by p2. And the period for 3 times f3x will be 2 pi by 2 p3. Am I correct? So it is nothing but pi by p3. Therefore, the period for this function f1x minus f2x plus 3 times f3x is nothing but LCM of pi by p1, pi by p2 and pi by p3, which is equals to LCM of pi, pi and HCF of p1, p2 and p3. Is it clear? LCM of pi, pi and pi will be nothing but your pi, and HCF of p1, p2, p3. Since they have said that the period of this function is pi, therefore HCF of p1, p2, p3 must be equals to 1. Is it clear? Then only you will get its period as pi. Therefore, the conclusion that we have drawn from here is HCF of p1, p2 and p3 will be equals to 1. Is it clear? Now, see the second one. They have said that the period for f1x plus 2 times f2x is pi by 2. So the period of f1x, just now we have calculated, it is pi by p1. Similarly, the period for 2f2 will be pi by p2. Is it clear? Now, to get the period as pi by 2, we have to find LCM of pi by p1 and pi by p2. So LCM of pi by p1 and pi by p2 will be LCM of pi comma pi divided by HCF of p1, p2. Is it clear? Now LCM of pi will be nothing but pi divided by HCF of p1, p2. Since the period is pi by 2, hence HCF of p1, p2 has to be equals to 2. Yes or no? Therefore, the conclusion we can draw is HCF of p1 and p2 is nothing but 2. Right? Now see the third which is given, the third function which is given is f1x plus 10 times f3x. So period for f1x is pi by p1, period for f3x will be pi by p3, right? Now they have said the period for this function is pi by 3. Now, what is the period? Now, period will be LCM of pi by p1, comma pi by p3, right? Which is LCM of pi comma pi divided by HCF of p1 and p3. LCM of pi comma pi is nothing but pi. But HCF of P1, P3 has to be equals to 3 because they have already declared that the period for this function is pi by 3. Therefore, the conclusion that we can draw from here is HCF of P1, P3 is nothing but 3. Is it clear? Now, you have to check one thing. We have been said to find the minimum value of P1 plus P2 plus P3. Now, to find out the minimum value of P1 plus P2 plus P3, we have to find the minimum value of P1, P2 and P3. Because if you find the minimum value of P1, P2, P3 and if you add it up, we will always get the minimum value of that summation. Yes or no? Okay. Now the question comes, what is the minimum value of P1, P2, P3? Let us start from the last one. You see, HCF of P1 and P3 is 3. What does it mean? What does it mean? It means that either P1 is 3 or P3 is 3 or both. Because HCF of P1 and P3 is 3 can be obtained by different values of P1 and P3. Say for an example, if P1 is 6 and P3 is 15, then its HCF will be 3. If say P1 is 15 and P3 is 24, then also HCF is 3. But we are in the search of finding minimum value of P1 and P3. Thus we have chosen at least one value of P1 and P3 must be 3. Yes or no? If P1 is 3, P3 can be multiples of 3. But if P3 is 3, then P1 will be multiple of 3's. Then only you will get the HCF of P1 and P3 as 3. Yes or no? Now, the question comes, which value we will take? Will we take P1 as 3 or P3 as 3? Think about it. You see, before taking any decision, you have to see the second part. In the second part, they have given that HCF of P1 and P2 is 2. That is, one of P1 and P2 is 2 and the other one is multiple of 2. Is it clear? Now it is clear that we have to take P3 as 3. P1 is 6. Why 6? Because P1 can take the multiples of 3. It can be 3, it can be 6, it can be 9, it can be 12 and so on. But we have to choose the least value of P1 in such a way that the second condition, that is HCF of P1 and P2 will be 2. HCF of P1 and P2 will be 2 means P1 as well as P2 has to be multiple of 2. So the least value of P1, which is multiple of 2, is nothing but 6. That is why we have assumed P1, the least value, is 6. Is it clear to all of you? Is it clear to all of you? Okay, so P1 is 6. Now you see, HCF of P1 and P2 is 2 because in this case, your P2 will be 2 and as we got from here, P1 is 6. So HCF of 2 and 6 is nothing but 2. Is it clear? So your P2 will be 2, P3 will be 3 and P1 will be 6. Is it clear? Then this condition and this condition are satisfying with the least values of P1, P2 and P3. Now the question comes, if it satisfies this first condition, then we will take those values as our final values. Final minimum values, right? Now we can see if P1 is 6, P2 is 2, 6, 2 and P3 is 3. The HCF of 6, 2 and 3 is nothing but 1, which is satisfying this condition. Yes or no? Therefore, the minimum value of P1, P2, P3 are 6, 2 and 3 respectively. Therefore, the summation will be 6 plus 2 plus 3, which is nothing but your 11. 11 is the minimum value of the summation of P1, P2 and P3. Is it clear? Is this question clear to everyone? Okay, let us move for another problem. Now see this problem. Here they have given f of x minus 1 plus f of x plus 1 equals to root 3 fx. Is it clear? Now, before starting the sum, I will request all the viewers to please see my video on differential calculus functional equation. The link is given below. I have also given the link in the description section. So please see the video, then you see this problem, otherwise you won't be able to understand what I am doing right here. Okay, now those who have seen the video, please see how I am doing the sum. Here I am replacing x by x plus 1. So we are getting fx plus f of x plus 2 equals to root 3 f of x plus 1, correct? Taking everything in the left hand side, we are getting f of x plus 2 minus root 3 f of x plus 1 plus fx equals to 0. Therefore, the quadratic equation will be m square minus root 3m plus 1 equals to 0 implies m equals to, so which is in the form of alpha plus minus iota beta. Here alpha is root 3 by 2 and beta is half. Okay, therefore our theta will become tan inverse mod beta by alpha, which is nothing but tan inverse 1 by root 3, which is pi by 6. Is it clear? Therefore, our function will become a is theta x, that is pi x by 6, plus b is minus pi x by 6. Yes or no? Therefore, we can write it as a plus b cos pi x by 6 plus iota a minus b sine pi x by 6. Okay, now they have given f5 is 100. So we can write f5, which is equals to 100, equals to a plus b cos 5 pi by 6 plus iota a minus b sine 5 pi by 6. Yes or no? Now if we compare, we are going to get a plus b cos 5 pi by 6. Cos 5 pi by 6 can be written as pi minus pi by 6, which is equals to 100, and a minus b sine 5 pi by 6 is equals to 0. Okay, so we are having a plus b minus root 3 by 2 equals to 100. That gives you a plus b equals to minus 200 by root 3. Am I correct or not? Okay, therefore my function fx becomes, your function fx is a plus b cos pi x by 6 plus iota a minus b sine pi x by 6. So this part is nothing but 0. So we are having fx as a plus b is nothing but minus 200 by root 3 into cos pi x by 6. Yes or no? Have you understood? So this is my function fx. Now we can see it easily that this function is a periodic function with period 2 pi by 6. That gives you 12. Therefore, the function fx is a periodic function with period 12. Is it clear? Therefore, we can write sigma r equals to 0 to 99 f of 5 plus 12r. That gives you what? Tell me fast. When I put r equals to 0, we are going to get f5. When we are putting r as 1, then we are getting f of 5 plus 12, which is again equals to f5, because the period of the function fx is 12. When we put r equals to 2, then we are getting f of 5 plus 12 into 2, which is again equals to f5. And this goes on. So how many times we will write this? How many times we will write f5? Because here r starts from 0 to 99. So there are 100 such terms. Is it clear? So we are writing f5 100 times. So it will be what? 100 into f5. Is it clear to all of you? Have you understood this? Therefore, our answer will be what? 100 into f5. The value of f5 is 100. So our answer is 10,000. Is it clear to all of you? Therefore, the value of the given expression is nothing but 10,000. Is it clear? Okay. Now let us move for next problem. See this question. They have said that fx is an even periodic function with period 2 and fx is x for all x in the interval 0, 1. Then we have to find out the value of f of 3.14, right? Now, since fx is a periodic function with period 2, so let me just write it that fx is an even function and fx is a periodic function with period 2. And they have said that fx equals to x for all x belongs to 0, 1. So let me just draw the diagram. Fx equals to x, it is this graph. It is a straight line passing through the origin. This is 1, right? Now, since the function fx is an even function, therefore, we will have y is equals to minus x. Since fx is an even function, so we will have whatever part is in the first quadrant, we will have the same part in the second quadrant also. That is, it is the mirror reflection about the y-axis. Is it clear? Since fx is an even function. So from 0 to 1, the function fx is x. Therefore, from minus 1 to 0, the function fx will be minus x. Is it clear? Now we see that the function is a periodic function with period 2. Therefore, from minus 1 to 1, this length is 2 units. Okay? So, the graph will repeat this same form. So, the graph fx will look something like this. Yes or no? Tell me yes or no. Right? This is our 2, this is 3, this is 4 and so on. This is again minus 2, minus 3, minus 4 and so on, right? So this is the graph of the function fx according to the given conditions. Is it clear? Now we can easily see that your f of 3.14, we have to find out the value of f of 3.14. Now 3.14 lies somewhere here. Okay, let us say this is 3.14. So what is the equation of this line? What is the equation of this line? This equation is nothing but y equals to minus x plus 4. Yes or no? Because the slope of this line is 135 degree. Tan 135 degree is minus 1. So y equals to minus x, and it is passing to the point 4, 0. Therefore, the equation of this line will be y equals to minus x plus 4. That's it. Is it clear? Therefore, the value of f of 3.14 is nothing but minus 3.14 plus 4, which gives you 0.86. Is it clear? So this is your answer. Have you understood this? It is a simple sum if you can understand the definition of an even function and what is periodicity of any function. If you can understand only these two things, you can simply draw the diagram. And the moment you can draw the diagram, you can easily find out the value of f of 3.14, which is given here. Is it clear to all of you? Okay.